Section G on z-scores is taken from 8.7, the worksheet, and we're starting looking at number 1, part A. An exam produced grades with a mean score of 74.2 and a standard deviation of 11.5. Find the z-scores rounded to the nearest 100th for each of the following test scores. We're just going to look at one of them to give you a start here. Assume the distribution for the exams to be normal. Also write a sentence interpreting the meaning of each z-score in relation to the mean. So, we have a test score and a z-score is your test score, your actual value, so 54, minus the mean. So our mean is 74.2 divided by the standard deviation. So we first subtract the numerator, so 54 minus 74.2 and get negative 20.2 over 11.5. Divide, and we get a decimal, and so we're going to approximate. We get negative 1.757 roughly. And then lastly, we need to write a sentence what this means. So this means that 54 is about 1.757 standard deviations to the, because it's negative, we're going to say to the left of the mean. If it was positive, we'd say to the right of the mean. Number 2, part B, we're going to look at. A sample of textbooks has a price, a mean price of $120 and a standard deviation of $20. Find the textbook price that corresponds each of the z-scores. So assume the distribution of textbook prices is normal. So again, we're going to use the formula that a z-score is your value minus the mean over the standard deviation. And so we're going to plug in what we do know. We know that 1.2 is our z-score. We don't know the price of this textbook. We know the mean is $120, and we know the standard deviation is $20. And so here's an equation I have to solve. I'm going to cross multiply, and I get x minus 120 is equal to 20 times 1.2. Or x minus 120 is equal to 20 times 1.2 is 24. Add 120 to both sides, and you get x is 144. And we're talking dollars here. Number 3, what does it mean to say that x equals 152 has a z-score or a standard score of 1.5? Assume the distributions are normal. So this means that 152 is 1.5 standard deviations positive, so we're going to say to the right of the mean. Number 6, a married couple are employed by the same company. The husband works in a department for which the mean hourly rate is $12.80 and a standard deviation of $1.20. So we have the husband. The wife is employed in the department where the mean is $13.50 with a standard deviation of $1.80. Relative to their departments, which is better paid if the husband earns $14.60 and the wife earns $15.75. So when it says relative to their departments, we're talking, let's find their z-scores. So the husband earns $14.60. The mean of his department is $12.80. And the standard deviation of his department is $1.20. And this is his z-score. For the wife, she makes $15.75. The mean of her department is $13.50. The standard deviation of her department is $1.80. So let's work these through. $14.60 minus $12.80 is $1.80. And $1.80 divided by $1.20 is $1.50, or 1.5. So the husband is 1.5 standard deviations to the right of the mean. For the wife, we have 15.75 minus 13.5, which is 2.25 over 1.8, which is 1.25. Notice how the husband's z-score is greater than the wife's z-score, so which is paid better. So the husband is paid better relative to his department since his z-score is larger than the wife's. Notice the wife does make more money. She makes $15.75 where he makes $14.60, but within their respective departments, the husband is higher paid.